Okay, Nick has won the Cash for Life lottery. He has a choice of accepting 4,000. Oh, I forgot to change that part. Ah, jeez.
No, you put it.
Now we're back to 1,000 a week. That's the real Cash for Life. 1,000 a week. Okay? So he has a choice of accepting $1,000 a week for 25 years, or he can take a lump sum of $500,000 right now. Nick has been assured by the bank he can get a bank account that will receive 5% annually compounded weekly. Okay? So the good part about this question is our payments are per week and our compound period is per week. So there's no extra calculation at the end we have to do. Whatever we find will be the answer we're looking for. What we need to do, though, is we need to figure out if the weekly payments of $1,000 are essentially worth the present value of $500,000. Okay? So we take this present value formula. Okay? And what we're saying is our R here in this question, or our regular payments, I think we did in red last time, are $1,000 a week, right? So you get 1,000 every week. Because it's weekly, that's our compound period. So C is going to equal what? 52. There's 52 weeks in a year. Make sure you guys know that. Okay? C equals 52. Okay. We have our regular payments at 1,000. C is 52. Our interest rate.
0.05.
Yeah. Our R is 0.05. So we're going to calculate I on the side. I is 0.05 divided by 52. It's going to give us what?
9,000.
Oh, very small number, so let's put it in here. 0.123. There you go. There's our I. N is the number of years. How many years are we? 25. How many compound periods? 25 times 52. Yeah. 1,300. So there are 1,300 weeks in 25 years. So that's going to be our N, or our exponent in this question. So we go to solve this question. We're looking for what this would be in terms of present value. What would that be worth right now? You get paid for 25 years, $1,000 a week. So we get $1,000 as our regular payments.
1 plus.
1 minus 1 plus, it's a very small number, 2, 3, to the power of negative 1,300. It didn't quite fit, but. And then all divided by that decimal once again, which is 0. And there's 3 zeros, 961. Okay. So we actually need to just solve this question. We're going to go through this formula. So, according to BEDMAS, we deal with brackets first. So I'm going to simplify my bracket. I have 1,000 on the outside. 1 subtract 1.000961 to the power of 1,300. All divided by. We're going to put this to power now. 1.123961 to the power of 1,300. Oh, going to give us a pretty good number. Oh, sorry. Negative. Thank you. Thank you very much. 1.000961 to the power of negative 1,300. All right. Gives us this number here. So we get 1,000. 1 subtract 0.28687 is good enough for now. Still all divided by 961. We subtract this. 1 subtract 0.2 0.7. 1,000 times 0.71313, still divided by. We take this value, multiply it by 1,000. gives us 713. It's going to be interesting to see what we're going to get. 713.13 divided by this decimal, because this is a really small decimal, divided by 0.000961. The present value would be $742,070.75. So what that means is that in terms of the equivalency, because we have a bank account where if I were to receive $1,000 a week, I could technically put it into that bank account, earn 5% interest, and that $1,000 a week would be like an annuity. Okay? So what we're saying is every week, instead of spending that $1,000, which I know for Cash for Life you most likely would like to, but just in terms of the equivalency, in terms of money, you can actually take that money, make it an annuity, put it in every single week and earn interest. And the present value of that would be $742,000. So what they're offering you as a lump sum, not enough money. Okay? You wouldn't want to take this. It's more in your interest to take that money and invest it. Now, I understand you may not invest it.
Couldn't you take the $500,000 and invest it in for 5%?
And it won't surpass what you would get as a annuity of $1,000 a week.
After 25 years, it won't be more than 700.
Well, think of it like this: your $500,000 is not an annuity. Your $500,000, you're not going to get any more money. It's just going to get compound interest. So I take $500,000, I just throw it in there, I earn compound interest on it. The $1,000, I get $1,000 a week, and I'm going to get interest on it. So I'm going to put $1,000, $1,000. By the time we get to 25 years, we're probably up and towards $1 million odd in terms of our payoff, plus we're earning interest. So it'll start off slower, but by the end of 25 years, that $1,000 a week will have earned much more money than just taking $500,000 right now and sticking it in the bank.
The whole thing is once a week.
That's very true. Who knows?